Hello, my name is Vladislav. I am a technician at VTM Group, and today I will be presenting the SBR-10 balancing machine. This machine is designed for balancing the turbocharger cartridge assembly at operating speeds. This is achieved by supplying compressed air from the air network, and the rotor speed on this machine reaches 200,000 revolutions per minute. The machine is designed for the final balancing of the car's turbocharger. This is necessary because, at the previous stage of balancing, the turbocharger rotor is still considered a rigid rotor. When operating at high speeds, it passes its first, second, and in some cases third and fourth critical speeds, which causes the rotor to bend due to its design under the influence of centrifugal force and a provocateur of imbalance, so to speak. In other words, on this machine, we intentionally introduce imbalance in order to eliminate forces that will affect the rotor's deflection. The SBR-10 machine consists of a cabinet housing the tested turbo compressor cartridge. It is enclosed with a protective cover featuring a glass panel. It has a backlight, a speed sensor, and a vibration sensor located in the table on which the cartridge itself stands. The housing activator for air supply, flexible piping to the housing activator, oil supply. A magnetizer is also included in the set. At the bottom of the machine, we can observe the oil station. On the right side of the machine is the operator's workstation, where there is a computer with pre-installed software, a manometer for measuring air pressure in the system, a manometer that shows oil pressure in the system. Oil heating toggle switch. The temperature is preset now at 43 degrees with a hysteresis of 1 degree. Oil supply stop button, oil supply start button, air supply stop button, and air supply start button. There are also controls for the oil pressure in the system on the front panel. On the right side of the stand, there's a breaker and a light that says Power On. The machine is connected to a 220-volt power supply and an air line with a pressure ranging from 8 to 10 bar. To successfully install the turbine cartridge on the machine, you must adhere to the following order of operations. The initial action involves taking the cartridge. Find the drain hole, direct it down to the vibration table, lift the clamping bar, and install the cartridge on the intermediate bar. A fitting for oil supply will need to be selected for the clamping bar. Several will be included in the set. We are installing the clamping bar. Next, we position the heat shield to the turbocharger housing in order to set an even gap around the perimeter between the cartridge and the heat shield. After that, we tighten the wing nuts. This must be done evenly. The gap is even. After that, we will connect the oil. Please close the lid and switch on the oil pressure. The oil pressure has increased. We can see that there are no oil leaks from the turbocharger cartridge. From below, we can see that the oil is trickling down in a thin stream, indicating that there is circulation. The next step is to select a ring from the tooling kit that will secure the heat shield. It should fit into this part with almost no gap. Next, we select another ring that will match the diameter of the turbine wheel. We install the activator housing onto the cartridge and tighten the knobs. When both knobs are tightened, we manually rotate the shaft to check for any binding. Currently, there is no binding. The ring is selected in such a way that when it is installed, there was a gap between the turbine wheel and the ring. That means it fits here comfortably and can be easily removed. If this gap is too large, you won't be able to accelerate the cartridge to maximum speed. A compromise is needed here. The next step will be installing the speed sensor. For this, we bring the adjustable platform, release this knob, and by adjusting the axis, we bring the speed sensor to the end of the shaft with a gap of 1 to 1.5 millimeters. It's about that. We tighten this wing nut when height adjustment is needed, loosen the rear wing nut, and adjust up and down with the wing nut. Then, we secure the knob at the back. We also bring the heat shield to the turbine cartridge initially, without any gap to ensure full contact. After that, we move it back to a distance of 1 to 2 millimeters. And also secure it with the knob on top. During operation, when you make several starts, avoid holding this part. It will be quite hot. It's best to hold on to this knob on top, either right here. In the following, we will need to use a magnetizer to test the cartridge. A mark is applied on the turbocharger cartridge. Here's the black one. It is needed for the operator. We position this mark vertically upwards. Next, take the magnetizer, which also has an upward position marked on it, and an arrow indicating the direction in which it should be moved. We set it up, and we pass it several times. Touching the nut, we magnetize it. 3 or 4 times is enough. There are 2 screws on the body of the magnetizer. By loosening them, we can adjust the width of the jaws. Next, we close thermal shield, closing the lid. And now we move on to the display. Here we select the parameters. The program will automatically start when the stand is turned on. Go to Settings. Select the turbo from the list of companies. In this case, it's KKK and BV39. Press Select. Here, we can enter its serial number if necessary. If not, press Exit. The tolerance values will be set automatically. Next, we initiate the rotation and test the turbo. To start the test, you will need to press the Send Data button and the button for air supply. We conduct the test. The test cycle has been completed. The stand automatically accelerated the turbocharger cartridge to 135,000 revolutions and stopped the rotation. In doing so, measured the imbalance and the phase where the imbalance provocateur is located. On the screen, we see a blue and a red graph. The blue graph represents vibration acceleration, which is measured in G units. The red graph measures the angle at which the imbalance provocateur is located, and it is measured in degrees. In order to rectify the imbalance, it is essential for us to identify the location on the graph that marks the beginning of the first third of the second peak. So this is our entire first peak, and this is the second peak. The first third of the second peak is in the range here from 0, somewhere around here, and up to this point. And somewhere in this place, in this area, there will be a provocateur of imbalance. To find it on the turbocharger cartridge, we will need to open the lid. On the compressor wheel, we see our mark. We will be able to locate the provocateur once we place the marker vertically from above. And we will saw in the corner where it will be shown on the graph, that is, on the left side of the axis of rotation. That is, somewhere at this point, it will be necessary to eliminate the imbalance. You can eliminate the imbalance with a file or a more automated device like an engraver. I recommend cutting the nut, as the nut is a more expendable material, costs less than the turbocharger wheel, and also weighs less. The specific weight of the material is greater, so a smaller volume will need to be removed to achieve the desired result. So after eliminating the imbalance, we close the thermal shield back, close the cabinet, press send data once more, and the air start button, and we see the second launch. Now we simultaneously see two overlapping launches, red and blue, which represent the current measurement. Lighter red and light blue are the previous dimension. We see how the vibration level has changed and that it is below the green line, meaning it is within the acceptable range. We can also disable the phase display to declutter the chart from potentially unnecessary information. For greater clarity, when the magnitude of the imbalance is very small, we can apply a magnification of 2 or 4 times. The stand is equipped with automatic and emergency shutdown of the cartridge rotation in case the vibration exceeds the limit. That is, even when the start button is pressed, the air graph will not have been drawn yet, meaning the operator will not see it yet, but the stand will stop the cartridge from spinning and display a message on the screen stating that the vibration has increased, and we have stopped the cartridge rotation in an emergency manner. This may indicate a bent shaft or a violation of the cartridge assembly technology. The machine is equipped with the following accessories. They can be divided into groups for air supply, and oil drainage. So, for air supply, the standard configuration includes a right and left rotation activator housing. I have one in my hands, and the other is installed on the machine, accordingly with clamps. Please note that they have different threads, meaning the activator for left-hand rotation will have a right-hand thread. On the activator housing for right-hand rotation, there will be a left-hand thread. The non-standard set, the extended one, will include 2 more cases, one of which is for larger cartridges, and accordingly, rings for them. It's the same here, left and right threads, spacer rings for mounting the activator housing on the turbocharger. They have a slot. There are quite a few of them as well. The rings without a slit are placed on the turbine part and are selected according to the shaft diameter. Next, we have a thermal shield, which is installed in place of this heat shield, depending on the size of the compressor wheel. Also included in this expanded set of equipment, so to speak, will be a heat shield of an even larger size. Next is the coupling nut for connecting the machine to your airline. Please note that the counterpart of the coupling is attached to the machine. The second part fits you, and as this is an inch coupling nut, the pipe section must be at least 1 inch. Next, There will be equipment for oil drainage of this type. Such sample, followed by the equipment for draining and supplying oil. This is a Volkswagen T5. And the next part of the equipment is the spacer rings. They are needed for these rings here, in case they need to be moved away from the impeller. The set includes two pieces, like the activator housings. The clamp can press the turbine if the oil is supplied from the side. These adapters will be needed. This adapter and this one. If the oil supply is from above, then these two adapters and another one installed on the stand. The connection to the air duct is made using a coupling nut that comes with the kit. The cross-section of the air connection pipeline must match the fitting. The oil station included in the set has a capacity of no more than 10 liters. It has a fitting for draining the oil, and for supplying oil, a filler neck, a dipstick, fine filter. Also inside is a mesh coarse filter, and the pump too. I recommend using 10W40 oil in the oil station and changing it at least once a year. The oil station has a heater for warming the oil circulation pump, and also a temperature sensor. To ensure the successful and safe operation of VTM group equipment, it is necessary to connect the grounding circuit to the equipment. The first grounding point can be found on the machine's casing, and the second grounding point is situated on the casing of the oil station.